Good morning, students. Thank you very much, students, for clicking on my video. I am your Nagini ma'am, chemistry mentor. In today's section, I am going to discuss about molecular orbital energy level diagram, students. This topic is from chemical bonding lesson 11th class. Okay, Nama. Now, I am going to discuss about the energy increasing order for the molecular orbitals up to 14 electrons, students. So, first, I am going to discuss about up to 14 electrons. Next, after 14 electrons, what is the energy increasing order? Okay, that all I'm going to discuss. So first of all, the energy increasing order for the molecular orbitals up to 14 electrons. Clear? Energy increasing order, Nana. Energy increasing order for molecular orbitals up to 14 electrons. So up to 14 electrons, one energy increasing order is there, Amma. After 14 electrons, another energy increasing order is there. Okay, now one by one we'll discuss, students. So first of all, energy increasing order for the molecular orbitals up to 14 electrons. So what is the energy increasing order here? Now see, students, sigma 1s less than sigma star 1s less than sigma 2s less than sigma star 2s less than pi 2p y pi 2p z less than sigma 2p x less than pi star 2py pi star 2pz less than sigma star 2px. Clear? So this is the energy increasing order, students, for the molecular orbitals up to 14 electrons. Okay, now up to 14 electrons, and after 14 electrons, what is the energy increasing order? See here, sigma 1 and sigma stars, what are they? Those are all anti-bonding molecular orbitals, students. Are you clear? Star there means that is anti-bonding molecular orbitals. These are bonding molecular orbitals. Okay, Nama. Now, energy increasing order for the molecular orbitals after 14 electrons. Okay, na? After 14 electrons, what is the energy increasing order? Now see, students, after 14 electrons, what is the energy increasing order? See here, sigma 1 s less than sigma star 1s less than sigma 2s less than sigma star 2s less than sigma 2px less than pi 2py pi 2pz less than pi star 2py pi star 2pz less than sigma star 2px. Clear? So this is the energy increasing order after 14 electrons, students. After 14 electrons, what is this up to 14 electrons, after 14 electrons? Now we'll take example, students, some molecules I will discuss with you. Okay, now so in that examples I will discuss this energy increasing order up to 14 electrons, so after 14 electrons. Before going to that example, students, so first of all, these molecular orbital energy level diagrams, that means electronic, we know that elements electronic configurations, how to write, we know that energy increasing order is there. So like that only for molecules, how to write electronic configuration in this order. Are you clear? This is the energy increasing order, students. In this order only we have to write the electronic configuration of the molecule. Clear this one? For molecules we are writing the electronic configuration. Are you understanding? So from the electronic configuration of the molecule, students, we can explain the behavior of the molecule, students. Are you clear? So here the electronic configuration of the molecule, Lana, gives the information about the behavior of the molecule, Lana. Are you understanding, students? Behavior of the molecule. Now here see, from the electronic configuration of the molecule, from the electronic configuration of the molecule, students, of the molecule, we can explain the behavior of the molecule. We can explain the behavior of the molecule. Behavior of the molecule. Clear this one? Clear? So here from the electronic configuration of the molecule, we can explain the behavior of the molecule, students. What is the behavior of the molecule? So here what are the points belongs to the behavior of the molecule? See here, first one is stability. So first one, stability, students. Second one is bond order. Third one, bond length, bond order, nature of the bond. Third one is nature of the bond. What is third one? Nature of the bond. And fourth one is bond length. Clear? Bond length. And fifth one is magnetic nature. Magnetic nature. Clear, students? So these are all 5 points belongs to behavior of the molecule. So from the electronic configuration of the molecule, students, we can explain the behavior of the molecule. So behavior is nothing but stability of the molecule, we can explain, bond order, nature of the bond length, magnetic nature. So first I am going to discuss these 5 properties, students. After that we will discuss with example learner this all electronic configurations, how to write, how to draw the molecular orbital energy level diagrams, that all I am going to discuss. Okay, so first of all, stability. So what is the stability, students? Here stability is nothing but, here see, first one, stability. Stability means what we can say, Nana? If NB is greater than Na, the molecule is stable. Are you clear? If NB is greater than Na, the molecule is stable, students. Okay, molecule is stable. Okay, if NB is less than Na, molecule is unstable, Nana. Molecule is unstable. Clear? What is NB and Na? NB is nothing but number of bonding electrons and Na is nothing but number of anti-bonding electrons, students. Are you clear? Number of bonding electrons, number of anti-bonding electrons, NB, Na. So if NB is greater than Na, then molecule is stable. If NB is less than Na, molecule is unstable. Okay, these points just to remember, students. After we will discuss this all the properties in example learner, then you can understand there. Okay, so next one is bond order, students. What is the bond order? See here, next second property is bond order. Bond order formula, students, half into NB minus Na. What is the formula? Half into NB minus Na, students. Clear? Half into NB minus Na. So in this formula, students, we know that NB is nothing but number of bonding electrons. Clear? Number of, okay, bonding electrons. Number of bonding electrons. And Na is nothing but number of anti-bonding electrons. Anti-bonding electrons. Clear? Okay, number of anti-bonding electrons. Okay, this is about the bond order, students. Next, third point is what, Nana? Nature of the bond. So what is the nature of the bond? It is depends on bond order, Nana. If bond order is equal to 1, see here, nature of the bond. Third one is nature of the bond. So what about nature of the bond, students? What is nature of the bond? It is depends on bond order. That means bond order, if bond order is equal to 1, okay, now bond order is 1 2 3. If suppose I am taking the bond orders 1 2 3, bond order, okay, now values 1 2 3, what indicates, students? 1 indicates if bond orders 1 2 3. Okay, 1 2 3 indicates, okay, 1 indicates, students, single bond. Okay, 2 indicates double bond. 3 indicates triple bond between the atoms. Are you clear? So that means here bond order values, this is the value Nana. Bond order values 1, 2, 3 indicates 1 means single bond. That means in between the two atoms single bond is existing. If the bond order value is 2, then we can say that in between the two atoms double bond is existing. If suppose 3, then triple bond is existing. That is the nature of the bond. Are you clear? Nature of the bond. Okay, it is single bond or double bond or triple bond. Are you clear? Next, coming to the bond length. So what about the bond length, students? So bond length is mainly depends on bond length. Listen, bond length, it depends on bond order. Okay, that means we can say that bond order is directly proportional to the bond order, is directly proportional to 1 by bond length. 1 by bond length. That means bond order increases, bond length decreases, students. Clear? Bond order if suppose increases, then bond length, what happened, Nana? Bond length decreases. Clear? Bond length decreases, students. Very important. So bond order increases, bond length decreases. Are you understanding? Bond length decreases. This is the fourth property. Now coming to the fifth property, magnetic nature. Okay, magnetic nature. What is magnetic nature, students? Magnetic nature. Now see, Nana, here what is magnetic nature? Magnetic nature means if suppose bonding molecular orbitals all are paired, then we can say that that is the molecule is diamagnetic in nature. If all molecular orbitals are unpaired, suppose anyone, okay na, not all molecular orbitals bonding molecular orbitals are paired, then the molecule is diamagnetic. If it is unpaired, the molecule is which one, students? Paramagnetic. Are you clear, students? Understanding? If the molecule, okay, see here, molecular orbitals, molecular orbitals are paired. Paired means what, Nana? Diamagnetic. Paired means diamagnetic. Clear? Paired means diamagnetic. Understanding? So molecular orbitals are paired, diamagnetic, Nana. If molecular orbitals are unpaired means that is which one, students? Paramagnetic. Are you clear? So diamagnetic. Understanding? So molecular orbitals are paired, diamagnetic. Understanding? Diamagnetic. Molecular orbitals are unpaired. What happened? Molecular orbitals are unpaired, then what we will call? Paramagnetic. Clear, students? So you have to remember these points, then these 5 properties you remember, students. You can easily answer any type of questions in competitive exam, students. Are you understanding? So if NB is greater than Na, the molecule is stable. If NB is less than Na, molecule is unstable. Bond order formula half into NB minus Na. NB is nothing but number of antibonding electrons, and NB is nothing but number of bonding electrons. Nature of the bond. So nature of the bond is mainly depends on bond order. That means if the bond order values 1, 2, 3, there means that values indicates 1 means single bond, 2 means double bond, 3 means triple bond. Are you understanding? Next, bond length. See here, bond order increases, bond length decreases. That means bond order and bond length both are inversely proportional. Now coming to the magnetic nature, molecular orbitals are paired. What, madam, these molecular orbitals? I will show you in the next video, students. Understanding? So molecular orbitals, that all I will discuss in the next video. Diamagnetic, paramagnetic. Clear this one? So molecular orbitals are paired, diamagnetic. Molecular orbitals are unpaired, paramagnetic in nature. Now see, students, I am discussing the molecular orbital energy level diagram with an example, H2 molecule. Now coming to the H2 molecule, students, I am taking example H2 molecule. See here, how many electrons are there? H2 molecule. Now see here, in H2 molecule, I am writing the first of all energy. H2 molecule means how many electrons are present in H2, students? Hydrogen atomic number is 1, correct? Hydrogen atomic number 1 means how many electrons are there? 1 electron is present, correct? 1 atomic number, 1 electron. 2 hydrogen atoms there now. So that's why in 2 hydrogens, another hydrogen atom 1 electron. So total how many electrons, students? 2 electrons are there. Are you clear? So total 2 electrons we have. Understanding? 1 electron, total 2 electrons. Now up to 14 electrons, what I told you, energy increasing order, students, energy increasing order for this for the molecular orbitals up to 14 electrons. What order I told you, Nana? Sigma 1s less than sigma star 1s less than sigma 2s less than sigma star 2s less than next pi 2py pi 2pz less than sigma 2px less than pi star 2py pi star 2pz, okay, less than sigma star 2px. Clear? So this is the energy increasing order. This is applicable up to 14 electrons. Clear? Up to 14 electrons. So here only 2 electrons there, up to 14 electrons. This energy increasing order you have to follow. Here already I discussed you the energy increasing order for the molecular orbitals up to 14 electrons. Clear? So this order I am taking. Now see, students, in H2 molecule total 2 electrons are there. Now how to draw the energy level diagram? See here, a molecular orbital energy level diagram, Nana. Here hydrogen 1 electron. So hydrogen 1 means what is the electronic configuration? 1s1. Another hydrogen atom also 1s1. So I am taking here only 1s is there. So that's why you will get the only one diagram. See here, one diagram. This is s orbital. Okay. Now see, students, here this is bonding molecular orbital, this is anti-bonding molecular orbital, this is a first hydrogen atom. Here energy increasing order is in this order. Okay, this is energy increasing order. That means this is sigma 1s, this is sigma 1s, this is sigma star 1s, sigma 1s, sigma star 1s. Are you understanding? Because we have only 1s, we don't have any electronic configuration 2s 2p. So that's why up to here only you have to take the diagram, students. Only 1s there na. So sigma 1s, sigma star 1s. Are you understanding? So sigma 1s, sigma star, this is bonding. This down orbitals always bonding molecular orbital. This is anti-bonding molecular orbital. Okay, now this is the energy increasing order. So sigma 1s is less than sigma star 1s, correct? That is energy increasing order. Now this is the hydrogen atom, this is one hydrogen atom and this is another hydrogen atom, students. Okay, now this electronic configuration is arrow, which one? 1s. This is also 1s. In 1s how many electrons are there, amma? This is one hydrogen atom, this is another hydrogen atom. Okay, now here what is electronic configuration? 1s1, 1s, 1s. How many electrons there? 1 electron is there in 1s. Here also 1 electron. Clear? This is one hydrogen atom, this is another hydrogen atom. 1s, another hydrogen atom, 1s. One electron is present. Clear? One electron is present. Now these two electrons first enter into the bonding molecular orbital. Are you clear? This is bonding molecular orbital, this is anti-bonding molecular orbital. Are you understanding? Now these two electrons enter into the bonding molecular orbital. Clear this one? Here these two electrons are entered into the bonding molecular orbital. Okay, now I am writing the electronic configuration. See here, in sigma 1s how many electrons are there, students? I am writing electronic configuration. Okay, sigma 1s, how many electrons there? 2 electrons. Sigma 1s 2. Are you clear? sigma 1s2. In antibonding sigma star 1s, is there any electrons? No, it is empty orbital. So this is this much only electronic configuration. Are you clear? Now see here stability. Now coming to the stability, students, first before going to that, how many bonding electrons are there? Number of bonding electrons. Number of bonding molecular orbital. In bonding molecular orbital, how many electrons are there? 2. So that's the number of bonding electrons 2. Number of anti-bonding electrons, how many? Na anti-bonding molecular orbital, is there any electrons? No. So that's why Na value is 0. Now what is the bond order, students? Bond order. So here before that, here properties I told you. How many properties I told you? 5 properties. Stability, bond order. So first stability I am discussing. Stability, what I told, if NB is greater than Na, the molecule is stable. See here, NB, Na already we calculated. See here, now NB is greater than Na kada? Na na? Understood amma? NB is greater than Na. So that's why the molecule is stable. Are you clear? Molecule is stable. Next one, understanding. So that means H2 molecule is stable. Understood? H2 molecule is stable. Okay. Now we are calculating bond order. Now see students, what is the bond order formula? I told you already, half into NB minus Na. That means half into NB value how much? 2. Na value how much? 0. That means 2 by 2 how much? 1. So bond order is equal to 1, students. Are you clear? Bond order value 1. Now third property, what there, students? Nature of the bond. What I told you, nature of the bond. Nature of the bond is nothing but if bond order values 1, 2, 3 indicates, okay now, bond, single, double, triple bond. Now bond order value how much we got here? 1. 1 means what we can understand, in between the two hydrogen atoms single bond is existing. Understanding, if bond order is equal to 1, what is the nature of the bond? Single bond. Are you clear? That means how to represent hydrogen, hydrogen. Clear? That means in between the two hydrogen atoms single bond is existing. This is about the nature of the bond. Are you clear? This is the nature of the bond. Understood, amma? Nature of the bond. Okay, nature of the bond is completed. Next one is magnetic nature. Here bond length is nothing but if we compare with 2, 3 molecules, then we can say if which molecule is having the bond order value less, then bond length will be more. Are you clear? So already I told you bond order, bond length is inversely proportional. Okay now, so we are not comparing with other molecules, so I am not discussing about the bond length. Now coming to the magnetic nature. Now see students, magnetic nature, what I told you, magnetic nature, molecular orbitals are paired. If molecular orbitals are paired, diamagnetic. If molecular orbitals are unpaired, paramagnetic. Are you clear? Which are molecular orbitals? These are molecular orbitals. Clear? So these are which one, students? Molecular orbitals. These are molecular orbitals. Now with these arrow, this one, these two are atomic orbitals. Are you understanding? What is this? Atomic orbital. Clear? This is arrow. Which one? Atomic orbital. Understood? This one atomic orbitals. This one middle orbitals are which one, students? Molecular orbitals. So molecular orbitals are paired, what we are calling that diamagnetic in nature. Now see, it is paired kada, it is paired now. That's why the molecule is diamagnetic in nature. Are you clear? The diamagnetic in nature. So magnetic nature, diamagnetic. Clear? Understood, Amma? So this is about the H2 molecule energy, H2 molecule energy level diagram. Clear? So first up to how many electrons are there, first you count, then up to 14 electrons. After 14 electrons you have to take the energy increasing order, then you have to take only one is their electronic configuration. So that's a only one diagram. One is this is one hydrogen atom, this is another hydrogen atom. This is electronic configuration of H2 molecule. Clear? H2 molecule electronic configuration. This one sigma 1s2, Nb value 2, Na value 0. So Nb is greater than Na, so that's the molecule is stable. Next bond order is half into Nb minus Na, calculated 1. Nature of the bond is single bond. Okay, now that means in between the two hydrogen atoms single bond is existing. Magnetic nature diamagnetic, because here molecular orbitals are paired. That's a diamagnetic in nature. Understood, students? I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, Nana.